Hello everyone, welcome to you in this video lecture on mobility of mechanisms. This is lecture number 3 under the subject Theory of Mechanisms and Machines. This lecture is specially designed for the GATE aspirants of mechanical engineering and the students of mechanical engineering having 4-year semester course will also be benefited by this lecture. The contents of the lecture are as follows. What are those? Mobility of 4-bar linkage, Grashof linkage, Nongrashof's linkage, mobility of an offset slider crank mechanism, and at the end we will solve gate problems. So let us start with range of movement or rotatability. This is determined by Grashof's criteria. Range of movement and rotatability is determined by Grashof's criteria. Let us see. Grashof criteria predicts the mobility of a 4-bar linkage based on its length of the links. So Grashof's criteria predicts the mobility of a 4-bar linkage based on its link lengths only. Okay. So let us see what is Grashof linkage. If chain satisfies this condition, that is L plus L is less than P plus Q, then we call it a Grashof chain or Grashof linkage. Now let me explain what is the significance of this equation. L is the shortest link length, L max is the longest link length, and P and Q are the lengths of other two links. So L is the length of shortest link, L max is the length of longest link, and P and Q are the lengths of other two links. So if a 4-bar mechanism satisfies this condition, then it will call a Grashof chain or Grashof linkage. So let us note some important information about Grashof's linkage. Number 1. In a Grashof linkage, the shortest link can make complete rotation with respect to all other links, whereas the other three links can only oscillate with respect to one another, and this amount of oscillation is always less than 180 degree. So the shortest link length is L that can make complete rotation with respect to all other links, and the other links can only oscillate with respect to one another, and this oscillation amount is less than 180 degree. So this is a very important information, that is the shortest link can make complete rotation with respect to all other links, but the other links can only oscillate with respect to one another, and this amount of oscillation will be less than 180 degree. Second information. The oscillating links cannot cross the line of frame. That is, the oscillating links cannot cross the line of frame is the fixed link. So the three oscillating links cannot cross the line of frame. Now let us see what are the inversions of a Grashof chain. So in a Grashof's chain, L plus L max is less than P plus Q. So that is the length of shortest link plus length of longest link will be less than summation of other two links. So what are the inversions? So the inversions in Grashof chains is determined with the position of shortest link length, that is L. We will get one double crank mechanism when L is the fixed link. So let me explain what is double crank mechanism. A double crank mechanism is a mechanism in which the crank and the follower can make a complete rotation of 360 degree. So this is the crank, and this is the follower. So both the crank and follower can make a complete revolution, that is, it both can rotate 360 degree when L min is the fixed. Next one, we will get two crank rocker mechanism. What is crank rocker mechanism? In crank rocker mechanism, the crank can make a complete rotation of 360 degree, but the follower cannot make full rotation. It can oscillate only. And this will happen when L min is the adjacent to the fixed link. This is the fixed link and L min is adjacent to the fixed link. Then we will get two crank rocker mechanism. And we will get a double rocker mechanism when L min is the connecting rod or coupler. So this is the position of L min when it is a coupler or connecting rod. Then we will get a double rocker mechanism. So both crank and the follower cannot make a complete rotation, they will oscillate only. And every case you see, when it is oscillating, it cannot cross the frame. This is the frame. Here it is oscillating, it cannot cross the frame. Here also it cannot cross the frame. Now let me explain once again. So we'll get one double crank mechanism, that is both the crank and follower can rotate 360 degree. When we will get it? When L min is the fixed link. So the condition is that when L min is the fixed link. Let us see an animation. This is an animation of double crank mechanism. So green link is the fixed link, that is the shortest link, L min. Red color link is the crank and yellow color link is the follower, and both of them can rotate 360 degree. So both of them can complete a rotation of 360 degree. Now let me explain the reason why it can make a complete rotation. Because in the previous we have taken the information previously that the shortest link can make complete rotation with respect to all other links. So all other links also can make a complete rotation with respect to the shortest link. So now this is the shortest link, L min, and these two links, crank and follower, can make complete rotation with respect to the shortest link. This is information number 1. From information number 1 we will get what? That the shortest link can make complete rotation with respect to all other links. So oppositely, all other links can make complete rotation with respect to the shortest link. So when shortest link is the fixed link, the two links which are connected to the shortest link, that is the crank and the follower, can make a complete rotation. Now come to the crank rocker mechanism. We will get two crank rocker mechanism when L min is the adjacent link. So when L min is the crank or adjacent to the fixed link. So L min here is the crank or adjacent to the fixed link. So in this case what happened? This is the shortest link. It can make a complete rotation with respect to the fixed link. But this follower cannot make complete rotation. It can oscillate only with respect to other link. Not, this is not a fixed link, is not the L min. So here this follower can only oscillate, and L min can make a full rotation of 360 degree, and this oscillation cannot cross the line of frame and will be always less than 180 degree. Let us see an animation of an crank rocker mechanism. So here Green color link is the fixed link. Red color one is the L-mean, that is the crank which can make a complete rotation, and yellow color link is the follower which is oscillating only. So next is double rocker mechanism. When we will get double rocker mechanism? When L-mean is the connecting rod or coupler. So one double rocker mechanism we will get when L-mean is the coupler or connecting rod. Now this crank is connected with the fixed link and follower is also connected to the fixed link. So these three are not a shortest link, that is L-mean is at the coupler. So these two links can only oscillate with respect to the fixed link. So we'll get a double rocker mechanism. So let us see the animation. The blue color link is the fixed link and green color link is the L-mean, that is the shortest link which is at the coupler, and red color one is the crank and yellow color link is the follower. Both crank and the follower, that is red link and yellow link, is making a oscillation only, that cannot make a full rotation. So we have explained all inversions of our Grashof chain. Now let us move to a non-Grashof linkage. So when it is a non-Grashof linkage, if L-mean plus L-max is greater than P plus Q, it is known as a non-Grashof chain. So in Grashof chain it was L-mean plus L-max was less than P plus Q. Here in non-Grashof chain, L-mean plus L-max is greater than P plus Q. And here also you have some note about non-Grashof linkage. In a non-Grashof linkage, all links can only oscillate with respect to one another. So no one link can make complete rotation with respect to other links. So all links can only oscillate with respect to one another. In non-Grashof linkage, all four inversions are double rocker linkage. Why? Because no link can make full rotation with respect to any other link. So all will only oscillate and we will get all double rocker mechanism. So all four inversions will be double rocker linkage because all the links can only oscillate with respect to one another. But here the angle of oscillation can be more than 180 degree. In Grashof linkage, the oscillation angle was less than 180 degree. Here, the angle of oscillation can be more than 180 degree. In non-Grashof linkage, the oscillating links can cross the frame, but in Grashof linkage, oscillating links never cross the frame. We have seen that in Grashof linkage, oscillating link has never crossed the frame, but here it can cross the frame because the oscillation angle is more than 180 degree. The reason behind is that the oscillation angle is more than 180 degree. So let us see. Now let us come to the inversions of non-Grashof chain. For a non-Grashof chains, all four mechanisms are double rocker mechanisms. So all four inversions are double rocker mechanisms. So both the crank and the follower will oscillate only. None of them can make a complete rotation. But based on the position of Lmax, that is the longest link, we can classify double rocker mechanism into three. What are those? Let me explain. When Lmax is the fixed link, both the crank and the follower will oscillate in inward direction. So both will oscillate in inward direction when Lmax is fixed. and both of them have crossed the line of frame, that is the fixed link. So let me show you one animation of this. So here red color link is the Lmax, blue one is the crank, and green one is the follower. Both are oscillating in inward direction and both have crossed the line of frame. So when Lmax is fixed, both will oscillate in inward direction. Next one is when Lmax is the crank or adjacent to the fixed link. Then crank will oscillate in inward direction, but the follower will oscillate in outward direction. So an inward outward double rocker mechanism will get an inward outward double rocker mechanism. Now let me show the animation. Here red color link is the Lmax, and that is the crank also, and green color link is the follower. So red color is oscillating in inward direction, and green color is oscillating in outward direction. So one inward outward double rocker mechanism will be produced when Lmax is the crank or adjacent to the fixed link. Next one is both outward, when Lmax is connecting rod or coupler. So when Lmax is connecting rod or coupler, both the crank and follower will oscillate in outward direction. And let me show you the animation. Here red link is the longest link and it is the connecting rod, and this green color link is the crank and blue color link is the follower. Both are oscillating in outward direction. So inversions of non-Grashof chains, all inversions are double rocker mechanism, but based on the position of Lmax we can classify into both inward outward and both outward. Now let us come to another situation that is known as transition linkage. A transition linkage is intermediate condition between Grashof linkage and non-Grashof linkage. So what is the condition? The condition at transition linkage is Lmin plus Lmax is equal to P plus Q. In Grashof linkage, the condition was Lmin plus Lmax less than P plus Q. For non-Grashof linkage, Lmin plus Lmax was greater than P plus Q, and now here in transition linkage, Lmin plus Lmax is equal to P plus Q. In general, a transition linkage behaves just like a Grashof linkage. So transition linkage behaves just like a Grashof linkage. But in transition linkage, there are configurations where all links becomes collinear, which is called a uncertainty configuration. So in transition linkage, there is a configuration when all links become collinear, and this is called uncertainty configuration. Now let me explain this. So this is the difference between transition linkage and Grashof linkage. Transition linkage have only one difference when this uncertainty configuration arises. So let me explain what is this uncertainty configuration. Let us consider a special case. For this 4-bar mechanism O2A, B, O4. two links are equal length and other two links are also in equal length. So it will satisfy the condition of transition linkage. Let us consider O2A and O4B. One of them, O2A or O4B, is L-mean, and O2O4 or AB, one of them is Lmax. So Lmin plus Lmax will be P plus Q here, and this linkage is known as parallelogram linkage, where two links are in equal length and other two links are also in equal length, and this is known as a parallelogram linkage. So there will be a configuration when all links become collinear. How they will become collinear? Look at here. At this instant, all links becomes collinear. So O2A becomes crank, comes to the horizontal position, then AB is also at horizontal position, BO4 or O4B is also at horizontal, and this is the fixed link O2O4. So all links becomes collinear. From this is the uncertainty configuration. Why? Because from this condition, this linkage remains in parallelogram linkage or it can flips into anti-parallelogram linkage. So I have already shown you what is the parallelogram linkage. So from this uncertainty configuration, the linkage may remain into parallelogram linkage or it may flips into anti-parallelogram linkage. Let me show these figures. From these configurations, this link can move in a non-unique fashion. So there is an uncertainty. That's why it will move in a non-unique fashion. What are those? It may remain parallelogram linkage. It may rotate like this. It may remains the parallelogram, or it may flips into anti-parallelogram linkage. So this is the anti-parallelogram linkage, or it may flips like this. That cannot be determined by kinematics. We can ensure to remain parallelogram linkage by adding an extra link. I am going to show you. Before that, let me show the animations. So this is a parallelogram mechanism. So this is a parallelogram mechanism. Green color and blue color lengths are equal in length, and red and yellow color lengths are in equal length. So from now they are become collinear, and from this it remains parallelogram linkage. So at here it remains the parallelogram linkage. Now uncertainty arises that it may flips into anti-parallelogram. Let us see that animation. So here all these links becomes collinear, and from that it flips to an anti-parallelogram mechanism. So this cannot be predicted by the kinematics. This depends on the inertia of the links. So this is the motion of the link in non-unique fashion. It may remains into parallelogram linkage or may flips into anti-parallelogram linkage. Now it will remain in parallelogram linkage, and that can be ensured by adding one extra link. Now let me show that configuration. By adding this link number 5 here, which is equal with link number 2 and 4, this will the parallelogram mechanism will always remains in parallelogram linkage. It will always maintain the parallelogram. And in degrees of freedom class, that was lecture number 2, we have studied that link number 5 becomes redundant. So this is the reason behind that. That's why this link number 5 is added here. So to remain the mechanism in parallelogram configuration. Now, until this lecture, we have discussed about the mobility of a 4-bar linkage. Now let us come to mobility of an offset slider crank mechanism. Now we know the condition of a 4-bar linkage when it can rotate fully or it will oscillate. Now if we can convert a offset slider crank mechanism into a 4-bar mechanism, then we can apply the Grashof law to it. So our objective is to convert a to convert an offset slider crank mechanism into a 4-bar mechanism, and both will give the same kinematics. Is it possible? Yes, it is possible. How it is possible, I am showing to you. Say this is a 4-bar linkage O2A B O4, and this is link number 4, that is O4B, and length of link number 4 is L4. Now we have replaced link number 4 by this arrangement here. What is the arrangement here? We have put a arc, put a surface with arc radius r equal to L4 and put a slider here which can slide on this arc. So if r equal to L4, then these two mechanisms are equivalent and both will provide same kinematics. The center of the arc is at O4 and radius is L4, and we have removed L4 and put a, instead of that we have put a slider here which will move on this arc. So these two mechanisms will produce same kinematics. Now, so these are equivalent mechanism. Now if we put this O4, point O4 at infinity, then the arc will become a straight line and this will be converted to a offset slider crank mechanism. Now please, I am repeating once again. Now we have shipped this point O4 at infinity. Then what is the value of r or L4? R or L4 also becomes infinity, and the B and the arc will become a straight line, and that will become a offset slider crank mechanism. So this is an offset slider crank mechanism where offset is E, O2A is the crank and AB is the connecting rod. A slider crank mechanism may be considered as a 4-bar linkage in which one hinge point O4 goes to infinity, which I have explained already. So if I have replaced this slider and added a link whose hinge point is at O4 and O4 lies to infinity, then that 4-bar mechanism will produce same kinematics of this offset slider crank mechanism. So a slider crank mechanism may be considered as a 4-bar linkage in which hinge point O4 goes to infinity. So O4 goes to infinity and we have removed this slider by a link of length infinity. So what will be the link number 4? Link number 4 is O4B, where O4 at infinity and O4B is L4. Now all parallel lines meets at infinity. So we can consider O4 also lies on a parallel line which passes through O2. So we can consider O4 also lies at this line at infinity which passes through O2, and that is parallel to this line, and this line is what? That is perpendicular to the axis of this slider. Now at this condition, say O4 is here at infinity on the vertical line which is passing through O2. So O4B is L4 and O4O2 is L1. So what is the condition? What is E? E is what? E will be L4 minus L1. L4 is what? L4 is, say, O4 is here on a vertical line passing through O2 and O4 at infinity. So O4B is L4 and O4 O2 is L1. So L4 minus L1 will be equal to E. So all parallel lines meet at infinity. Thus, we can shift the hinge point O4 to the right such that the vertical line from O4 passes through O2. So O4 and O2 are in same vertical line. And I have described what is L4 and L1. So L4 minus L1 is equal to E. And this is a forward linkage. Now we can apply the condition of Grashof rules. So what is the Grashof rule? So for this is for case 1. So Grashof rule for obtaining crank, for obtaining the so Grashof linkage is called when Lmin plus Lmax is less than P plus Q. Now what is Lmin here? Lmin is L2, and what is Lmax? Lmax is L4 because O4 lies at infinity, and B is at E distance upward from the O2. B is above O2 by a distance E. So L4 is greater than L1 and L4 minus L1 is equal to E. So Lmax is L4 and Lmin is L2. So L2 plus L4 should be less than equal to L1 plus L3. Now L4 minus L1 is equal to E. So L2 plus E is less than L3. So this will act as a Grashof linkage when L2 plus L3 is less than L3. What is L2? L2 is the length of the crank, and what is L3? L3 is the length of connecting rod. Now L2 is the minimum link, and which is crank or adjacent to the fixed link. So O2 O4 is the fixed link and which is adjacent to the fixed link or crank. So we'll get a crank rocker mechanism. So this crank will rotate 360 degree. So here we'll get a offset slider crank mechanism. The crank can rotate 360 degree. Now say it is a simple slider crank mechanism when E is 0, not an offset slider crank. So what is the condition that the crank can rotate 360 degree? That is L2 less than L3. If length of the crank is less than length of connecting rod, then the crank can rotate 360 degree. Now we are coming for case 2, that is where point B is below from O2 by a distance E. So similarly we have shifted O4 on a vertical line which passes through O2. Say O4 is here. Now O4B is less than O4O2 and O4O2 is L1. So here what is the condition? L1 minus L4 will be equal to E. So here L1 is the maximum link length. This is the longest link length, and L2 is the minimum link length, and L1 minus L4 is equal to E. So for case 2, if we apply the Grashof condition, that is Lmin plus Lmax is less than P plus Q. What is Lmin? Lmin is similarly here L2 and Lmax is L1 because O2 is above from B by a distance E, and here L1 minus L4 is equal to E. So we'll get the same condition, L2 plus E should be less than L3 to become a Grashof link, and L2 is the adjacent to the fixed link, so this will be crank, it can rotate 360 degree. So here we get both the cases, we will get same condition. So to become a slider crank mechanism, slider crank means crank can rotate 360 degree. The condition is length of crank plus offset should be less than equal to length of connecting rod. So if this condition is satisfied, then we will get slider crank mechanism, otherwise we will get slider rocker mechanism. And for simple slider crank mechanism, E is 0, so L2 should be less than L3, that is length of the crank should be less than length of connecting rod. Now say for a simple slider crank mechanism and L2 is greater than L3. I am describing you at that condition the crank cannot rotate fully. So E is 0, so this is a simple slider crank mechanism. When this crank angle is 90 degree, so if AB is less than O2A, that condition the point B cannot reach to this line. So the geometrical features are not satisfied. So the crank cannot move 360 degree. So the condition to get slider crank mechanism or offset slider crank mechanism is length of crank plus offset should be less than length of connecting rod. With this concept, now let us solve these two problems. Check the rotatability of the input link in the mechanism. Why rotation of input link is important? Because sometimes we will couple this mechanism to a motor. A motor can rotate 360 degree. So there will be, in a mechanism, there must be a link which can rotate 360 degree. Otherwise, we cannot couple the mechanism with the motor. So let us check the rotatability of the crank. So this is a 4-bar linkage. So if it is a Grashof link or non-Grashof link, let us check first. What is the shortest link? 10. What is the longest link? 27. So 10 plus 27 is greater than 15 plus 20. So this is a non-Grashof linkage. Solution. So this is a non-Grashof linkage because 10 plus 27 is greater than 15 plus 20. So it will produce a double rocker mechanism and input length cannot make a complete rotation. Now let us come to the offset slider crank mechanism. Here length of the crank is 15 and offset is 10. So 15 plus 10 is greater than 20, which also disobeys the Grashof linkage, that is, this is a non-Grashof linkage and the crank cannot rotate 360 degree. The mechanism is a slider rocker mechanism, that is, the input link cannot make complete rotation. So what was the condition for slider crank mechanism? That length of crank plus offset should be less than length of connecting rod. Here it is greater than connecting rod because 25, 15 plus 10 is 25, greater than 22. So we'll get a slider rocker mechanism, that is, the input link cannot make a complete rotation. This is the explanation which I have told already. Now let us find mobility of this mechanism. This is a 4-bar mechanism. This is a problem of gate. 4-bar mechanism O2ABO4. What is the kind of mechanism? That is double crank, crank rocker, double rocker or parallelogram. This is not a parallelogram mechanism. By visually we can tell it. This is not a parallelogram. So let us check what is this. So this link is given crank length 60, fixed link is 240 and follower is 160. So this link length is unknown. So let us first find out what is the length of AB. How we can find it? We'll draw a horizontal line from A and this distance will be 160 minus 60, that is 100. So AB will be 100 square plus 250 square. So length of AB is 240 square plus 100 square, that is 260. what construction we have made? We have drawn a horizontal line from point A, and this, which from the intersecting point, the distance of B will be 160 minus 60, 100. So this is 100 and this is 240. So length of AB is 260 millimeter. Now what is L min? 60. L max is 260. So AB is the L max. P is 240 and Q is 160. So L min plus L max what? 320, and P plus Q is 400. So it is a Grashof linkage. So L min plus L max less than P plus Q. So thus it is a Grashof linkage. And what is the position of what is the position of shortest link? O2A, that is the crank or adjacent to the fixed link. So we will get a crank rocker mechanism. So shortest link is the adjacent to the fixed link. So we will get a crank rocker mechanism. So this is the answer. So answer B is correct. It is a crank rocker mechanism. We have completed our lecture here. Thank you for watching this video. I wish you best of luck in your GATE examination. Jai Hind.